We have several techniques now for finding solutions of systems of linear equations. So let's look at a few examples of applying our techniques. And for this first example, we have a word problem where we need to convert it into a system first, and after we do, we will apply one of our techniques. In this case, this example, we will use Gaussian elimination, Gauss-Jordan elimination. So here's the problem. We have a bookstore that sells graph paper notebooks and college ruled notebooks for different prices, $2.50 for each graph paper notebook, $2.30 for each college ruled notebook. The bookstore knows that it sold 500 notebooks, and it knows that it collected $1,186, but it doesn't know how many of each type of notebook it sold, so it might not know how to reorder more notebooks to fill up its stock. But there's enough information here for us to reconstruct that to figure out how many of each type of notebook was sold. So the unknowns in this problem are how many of each type of notebook. So let's use x and y to represent the unknowns. I'll let x be the number of graph paper notebooks that were sold. I'll let y be the number of college ruled notebooks that were sold. Now the total number of notebooks sold we know is 500, so if I add x and y together I should get 500. And the total money that was collected from customers is $1,186. So if I take the number of graph paper notebooks sold, that's x, multiply it by the price, $250, that's how much money we collected for graph paper notebooks. Similarly, since y is the number of college ruled notebooks we sold, y times $2.30 will be the total amount of money we collected for selling college ruled notebooks. And if I add those together, I should get the total amount of money we collected for all notebooks, which we know to be $1,186. So now these are two facts regarding the variables x and y. Those two facts are two equations that we can use to solve for x and y. There are several approaches to answering this. For this example, let's set it up as an augmented matrix. So we take the coefficients of x, put those in the first column, coefficients of y go in the second column, and the quantities on the other sides of the equal sign go in the third column. And then if we perform Gauss-Jordan elimination, either by hand or using a calculator, we end up with this matrix, which appears to have an identity on the left side in the first two columns. And we know once we reach that point, we can just read off the answers. The first row represents an equation that says 1x equals 180, so x is 180, and the second row represents an equation that tells us y equals 320. Now, this was a word problem, and so it should really have a word answer. X and y are variables representing real-world quantities, so we should express our answer in terms of those real-world quantities. The store sold 180 graph paper notebooks and 320 college ruled notebooks. This problem could also be solved using a matrix equation with an inverse instead. Both approaches should produce the same final result.